We'll start in 1 minute. We will start Chapter 9 today in Section 9.1. This is the section on solving quadratic equations using the square root property. The first thing we'll do, though, is discuss what a quadratic equation is in standard form. The standard form of a quadratic equation in the variable x is ax squared plus bx plus c equals 0. There's supposed to be a 0 there, where a, b, and c are constants, and a does not equal 0. Okay, so to reiterate the blunder there, the standard equation in the variable x, ax squared plus bx plus c equals 0. A, b, and c are constants. A cannot be 0, otherwise it would not be a quadratic equation. Some examples of quadratic equations in the variable x in standard form. This one, 3x squared minus 2x plus 1 equals 0. In this equation, a is 3, b is negative 2, and c is positive 1. In this quadratic equation, negative 2x squared plus 7x minus 5 equals 0. In this equation, a is negative 2, b is 7, and c is negative 5. Whenever you have a quadratic equation in standard form, you always have the following option. If you would rather not deal with a leading coefficient that is negative, such as negative 2, since it is an equation, you can multiply both sides by negative 1. So if you multiply every term on both sides by negative 1, you get the standard equation 2x squared minus 7x plus 5. And 0 times negative 1 is still 0. So those two equations, even though they differ by a negative, they have the exact same solutions. So keep that in mind. You may not see the standard form of a quadratic equation every time. So quadratic equations that are not in standard form can be written in standard form. Here is a quadratic equation that's not in standard form. Negative 2x plus 5x squared equals negative 7. So let's write it in standard form. On the left-hand side, we'll just rearrange the terms so we get 5x squared minus 2x, and then add 7 to both sides so that the right-hand side is 0. These two equations are equivalent, but this equation over here is the standard form. All right, the next example, negative 4x squared plus 9 equals negative 12x. We always have two options on how to write the standard form. On this one, we'll do both. If we just add 12x to both sides, we get negative 4x squared plus 12x plus 9 equals 0. This is standard form. The other option, every quadratic equation has two options for how to write it in standard form. The other one, if you add 4x squared to both sides and subtract 9, we could start by writing 0 equals 4x squared minus 12x minus 9. If you'd rather have the trinomial on the left-hand side, that's not a problem. Just write 4x squared minus 12x minus 9 equals 0. Okay, the next one. Negative 7 equals 6x minus 8x squared. One option is just add 7 to both sides. So we get 0 equals, and then rearrange the terms so that in the trinomial, the x squared term is the first one. So 0 equals negative 8x squared plus 6x plus 7. So this is fine. You can leave it like this. If you'd rather have the negative 8x squared plus 6x plus 7 on the left-hand side, you can do that. Or if you want to write 8x squared minus 6x minus 7 equals 0, you can do that. Later, when we learn how to solve any quadratic equation whatsoever, there will be, in my opinion, an advantage of having a coefficient of x squared that's positive. It's not required, but I think it's easier if you have a quadratic equation in standard form where the coefficient of x squared is positive. Okay, let's move on to the next page. The first thing we'll do is learn how to solve a quadratic equation using the square root property. Here is the square root property. If x squared equals k, this is just a quadratic equation. K just represents a constant. If x squared equals k, then one solution is x equals the square root of k, and the other solution is x equals the negative of the square root of k. An alternative notation for the same thing, if x squared equals k, then we can say that x is equal to positive or negative square root of k. So there are two solutions You could list the two solutions separately, or you could list the two solutions at the same time by using positive and negative. So that also represents two solutions. Okay, we'll start out fairly simple. Solve the following equations using the square root property. X squared equals positive 81. So we can write x equals the positive square root of 81 for one of the solutions, and the other one is x equals negative square root of 81. The square root of 81 can be simplified, so x equals 9 and x equals negative 9 are the two solutions. You can visually check that each one of those is a solution to the original equation. When x is 9, 9 to the second is equal to 81. That's true. And if x is negative 9, the number negative 9 squared, that means negative 9 times negative 9. That's also equal to 81. Okay, the next example, y squared equals 13. So one of the solutions is y equals the positive square root of 13. The other solution is y equals the negative square root of 13. So if you want, you can just write the two solutions at once, y equals positive or negative square root of 13. Hey, you don't have to list both methods, just one or the other is fine. Okay, we'll go on to the next level, only slightly more difficult. So apply the square root property to this. The binomial y plus 3 squared equals 16. So take a few seconds and type in the solutions for y on that equation. You can probably do it within 20 or 30 seconds. Okay, type in the simplified answers. There are two solutions. Do you know what they are?
7, negative 7.
One of them is correct. Okay, let's go through this. We have a binomial squared equals 16. So this does look a little bit different than the square root property, but the property still applies. Since we have y plus 3 squared equals 16, we can write y plus 3 equals the positive square root of 16. And the other one, y plus 3 equals the negative square root of 16. The square root of 16 is 4. We'll go ahead and put in the steps. Y plus 3 equals 4. And the other one, y plus 3 equals negative 4. And then solve for y. Y plus 3 equals 4. Subtract 3, we get y equals 1. And the other one, subtract 3, we get y equals negative 7. And the equation has two solutions, positive 1 and negative 7. These two solutions are pretty easy to check visually. When y is 1, inside the parentheses, 1 plus 3 is 4, and 4 to the second equals 16 is true. When y is negative 7, inside the parentheses, negative 7 plus 3 is negative 4, and the number negative 4 squared is also positive 16. Okay, the next example, the binomial x minus 5 squared equals 17. So apply the square root property. This time I'll write using the alternative notation, y minus 5 equals positive or negative square root of 17. And then we can add 5 to both sides. And it's more common when after adding 5 to both sides, it's more common to see the solutions written this way, 5 plus and minus the square root of 17. So this is the common, perhaps the most common way to write the two solutions together. You can write the solutions separately. One solution is x equals 5 plus the square root of 17. The other one is x equals 5 minus the square root of 17. So there's a question, what's the difference between the top two equations? Well, they are separate equations. This equation is in the variable x, but we don't always have to use the variable x. We can have a quadratic equation in a different variable. I'm not sure if that's what you mean, but okay, let's move on. The next equation, 49x squared equals 169. On this one, you might want to do a preliminary step before applying the square root property. Okay, so this equation is just an example of a quadratic equation. So it's separate from all of the other examples that you see on this page. So you might want to first divide both sides by 49 and write it as x squared equals 169 divided by 49. Okay, then apply the square root property. If x squared equals 169 over 49, we can write x equals positive and negative square root of 169 over 49. Okay, this is one way to write the two solutions at the same time. One is positive, the other one is negative. The square root of 169 over 49 can be simplified. Both 169 and 49 are perfect squares. So we can write this as x equals positive and negative 13/7. So those are the two solutions. You have another option. It's an option. It's not required. You can write the solutions this way, positive and negative 13/7. If you want to list the solutions separately, one is positive 13/7 and the other one is negative 13/7. Okay, the next equation, negative 4y to the second equals negative 24. Before applying the square root property, divide both sides by negative 4. So we apply that preliminary step and we get y squared equals positive 6. This equation is in the variable y, so our solutions have to be in the variable y. So if y squared equals 6, we can write y equals positive and negative square root of 6. Okay, this one, y plus 4 quantity squared equals 25. So this is similar to a previous example. So first, we can apply the square root property right away. If y plus 4 quantity squared equals 25, then y plus 4 equals positive and negative square root of 25. Then we can write, then we subtract 4 from both sides, and we can write y equals negative 4 plus and minus 5, because the square root of 25 is 5. And this can be simplified further. So here we should, from here, write the solutions separately. One of the solutions is y equals negative 4 minus 5. The other one is y equals negative 4 plus 5. And then simplify further, negative 4 minus 5 is negative 9. So one solution is y equals negative 9. The other solution is positive 1. Negative 4 plus 5 is 1. All right, the next one. X minus 7 quantity squared equals 29. So apply the square root property. And we get x minus 7 equals positive and negative square root of 29. The square root of 29 cannot be simplified any further, so add 7 to both sides, we get x equals 7 plus and minus the square root of 29. If you want to write the solutions separately, you always have that option. It's not required, but you have that option. One solution is x equals 7 minus the square root of 29. The other one is x equals 7 plus the square root of 29. So I'm not sure if I'm answering the questions, but let me know if you need further clarification. Okay, let's move on to the next page. So this is a little bit different. Solve the following equations using the square root property. X squared minus 45 equals 0. This one doesn't appear to be ready to apply the square root property. But if we add 45 to both sides, we get x squared equals 45. Now we can apply the square root property. So if x squared equals 45, then x equals positive and negative square root of 45. Two solutions. And then we always simplify square roots when we can. So if we do this on the side, the square root of 45 is the square root of 9 times 5. And this simplifies to 3 times the square root of 5. Okay, if you list the solutions separately, one solution is x equals 3 times the square root of 5. The other solution is x equals negative 3 times the square root of 5. The alternative we can write x equals positive and negative 3 times the square root of 5. These are two different ways to write the two solutions. You don't have to do both. I'm just showing you that you have two ways of writing the solutions. Okay, I'll give you a few seconds to solve this equation. 3 times the binomial x minus 4 squared equals 150. And in about 20 seconds, I'll solve it. Okay, first thing to do is divide both sides by 3. So we get x minus 4 squared equals 50. And now we can apply the square root property. So there seems to be a question about when to use plus and minus and when not to. So I'm saying that you can do one or the other. You do not have to do both. I've been doing both a number of times. If we use the plus and minus on this one, x minus 4 squared equals 50, we write x minus 4 equals positive and negative square root of 50. And then we can simplify the square root of 50. So if we add 4 to both sides, we get 4 plus and minus. And then when we simplify the square root of 50, we get 5 times the square root of 2. This is one way to write the two solutions. One is x equals 4 plus 5 times the square root of 2. The other solution is x equals 4 minus 5 times the square root of 2. If you don't want to apply the plus and minus, you don't have to. You can write the two solutions separately. So two solutions written separately. One is x equals 4 minus 5 times the square root of 2. The other one is x equals 4 plus 5 times the square root of 2. So these mean the same thing. These mean the same. These give us the same answers. Or the two solutions. All right, the next one. This is a little bit different than what we've seen. We have the binomial 7x plus 1 squared equals 48. So it's all set up to write, to apply the square root property. So the first step, we can write 7x plus 1 equals positive and negative square root of 48. The square root of 48 can be simplified. So over here, why don't we simplify the square root of 48? 48 is 16 times 3. And the square root of 16 is 4, so we get 4 times the square root of 3. Okay, so in the next step, we'll subtract 1 from both sides, as well as write the simplified radical. Okay, so if we're going to subtract 1, we can write it as negative 1 plus and minus 4 times the square root of 3. And then in the last step, divide every term on both sides by 7. So we get x equals negative 1 plus and minus 4 times the square root of 3, all divided by 7. So this represents the two solutions. Okay, but I'll write the solutions separately. So in general, it's not required, but I'm just showing you how to do it. Okay, so just use the plus and minus one at a time. So one solution is -1 plus 4 times the square root of 3 over 7. And the other one is x equals -1 minus 4 times the square root of 3 all over 7. Okay, the next one, this is similar to the one we just did. This is already all prepared to apply the square root property. The binomial 8y plus 5 squared equals 50. So when we apply the square root property, we get 8y plus 5 equals positive and negative square root of 50. We'll simplify the square root of 50, and we'll also subtract 5. So in the next step, we have 8y equals -5 plus and minus 5 times the square root of 2. And then the last step, divide every term on both sides by 8. We get y equals -5 plus and minus 5 times the square root of 2, all divided by 8. Okay, next page. Solve the following equations by using the square root property. Okay, on this one, 3y squared minus 2y plus 3 equals 3. So here we're considering an equation that we will eventually learn how to solve by using the square root property. So this is just a harbinger of things to come. So I'll show you the process in this problem. So first we'll subtract 3 from both sides. So we get 3y to the second minus 2y equals 0. And then I will divide every term on both sides by 3. So 3y squared divided by 3 is y squared. And minus 2y divided by 3 is minus 2/3 y. And 0 divided by 3 is just 0. So what you're going to learn how to do within a day or two is create a perfect square trinomial by adding an appropriate number to both sides of this equation. So the term perfect square trinomial has come up before. So do you remember what a perfect square trinomial is? One way to think about what a perfect square trinomial is that the result of squaring a binomial is a perfect square trinomial. So in general, perfect square trinomials have two forms. So one form is a squared plus 2ab plus b squared. And the other form is a squared minus 2ab plus b squared. When we factor a squared plus 2ab plus b squared, we get a plus b squared, which just means a plus b times a plus b. And when we factor a squared minus 2ab plus b squared, we get a minus b squared. Okay, so on this one, for this equation, this is all set up to create a perfect square trinomial. But in so doing, we're not going to do anything that's illegal. We're just going to find a number to add to both sides of this equation so that the trinomial that results on the left-hand side is a perfect square trinomial. Okay, we'll go into more detail about how to do this shortly, sometime later this week. So I'll just explain to you in this example, if the coefficient of y squared is 1, we take 1/2 of the coefficient of y. The coefficient of y is negative 2/3, so 1/2 of negative 2/3 is negative 1/3. Then we square negative 1/3, and we get positive 9. Positive 1/9, I mean. So this is the number that we're going to add to both sides of this equation to create a perfect square trinomial. So we get y squared minus 2/3 y plus 1/9 equals 0 plus 1/9. The left-hand side is now a perfect square trinomial, which means that it can be written as a binomial squared. So how do we know what binomial to square to get y squared minus 2/3 y plus 1/9? Well, our preliminary work tells us since the first term in the quadratic expression is y squared, this has to have a y in it. And how do we know what follows? Well, what follows is 1/2 of negative 2/3, which is minus 1/3. So we write y minus 1/3 squared equals 1/9. You can verify by squaring y minus 1/3 and working backwards. You can get back to where we started from if you want to verify that this is correct. Okay, but now we have an equation that's prepared for us to use the square root property. So if y minus 1/3 squared equals 1/9, and we apply the square root property, we get y minus 1/3 equals positive and negative square root of 1/9. The square root of 1/9 is just 1/3, so we can add 1/3 to both sides, so we get y equals 1/3 plus and minus 1/3. We can simplify further. One solution is y equals 1/3 plus 1/3, or 2/3. And the other solution is y equals 1/3 minus 1/3, which is y equals 0. We can tell by looking that when y is 0, we get 3 equals 3, so that's definitely a solution. And then if you want to check 2/3, replace every y with 2/3. 2/3 squared is 4/9, and 3 times 4/9 is 12/9. So 12/9. And then minus 2 times 2/3 is minus 4/3. And then plus 3, we want to show that that's equal to 3. And sure enough, 4/9 is equivalent to 12/9. Yeah, so both solutions check out. Okay, let's look at the next example. 3x squared equals negative 75. Solve this by the square root property. First, divide both sides by 3. We get x squared equals negative 25. And then apply the square root property. We get x equals positive and negative square root of negative 25. We now know how to simplify square roots of negative numbers. So we get positive and negative 5i. So we recall the square root of negative 25 is the square root of 25 times the square root of negative 1, which we write as 5i. So those are the two solutions to that one. Okay, the next example, the binomial negative 3y plus 4 squared equals 49. So we apply the square root property. We get negative 3y plus 4 equals positive and negative square root of 49. Or negative 3y plus 4 equals positive and negative 7. Then subtract 4 from both sides. We can write it as negative 3y equals negative 4 plus and minus 7. If you want to simplify the negative 4 plus and minus 7 first, you can. But we have to write two different solutions. So why don't we do that? One solution will depend on negative 3y equals negative 4 minus 7, or negative 3y equals negative 11. And so y equals positive 11/3 is one solution. And then the other solution, negative 3y equals negative 4 plus 7, which is positive 3. And then divide both sides by negative 3, we get y equals negative 1. Okay, one more example. The binomial negative 5x plus 3 squared equals 64. This is all set up to apply the square root property. So we write negative 5x plus 3 equals positive and negative 64. Sorry, positive and negative square root of 64. And then negative 5x plus 3 equals positive and negative 8. And then negative 5x is equal to negative 3 plus and minus 8. If we divide both sides by negative 5, we get x equals negative 3 plus and minus 8, all divided by negative 5. But the solutions can be simplified further, so we do that. First, negative x equals negative 3 plus 8 over negative 5 is 5 divided by negative 5, which is negative 1. And the other solution, x equals negative 3 minus 8 divided by negative 5 is negative 11 divided by negative 5, which is positive 11/5. Okay, we're out of time. We'll solve quadratic equations tomorrow also. Go ahead and sign in for attendance.
Have a good day.
You too.
Thank you.